Welcome to our video on the surface area of cylinders. Today we're going to take a look at the surface area of cylinders. Like I said, to start, we denote total surface area as a capital T. Some people use an S, but I think it looks too much like a 5, so I try not to use it. I use T for total surface area. Finding the area of only the lateral faces, which is everything that's not the bases, is called lateral area, which will denote as capital L. Let's take a look at the net of a cylinder, and that's what we talked about in our last video. First of all, this is a base up top. It's a circle. All right. This is a base down low. It's also a circle. All right. And then that's a radius. And that's a radius. This is the height of our rectangle, and this rectangle is called our only lateral face. All right, you might not think there's a rectangle in any cylinders, but really if you think about a soup can and the piece of paper that's wrapped around the middle part there, if you unfolded it, it would be a rectangle. All right. The length of the rectangle is actually the circumference of the circle, so it would be 2 pi r. So we've already talked about this here. Our bases, there's 2 circles, right? So 2 circles are our bases. All right, there's one there and one down there. And the altitude is basically a line straight from the middle of each circle to the other. That's our height, or just the line that is on the outside of the circle if you're looking at on a 2-dimensional piece of paper as we are here. The lateral area of a right cylinder, the formula for that would be L equals 2 pi r h. Think about this. It's just a rectangle, right? Base times height. If you go back to a rectangle, base times height, 2 pi r h. And then for the total surface area, we're going to take that lateral and we're going to add on the 2 bases. There's 2 bases that are circles, so pi r squared. So 2 pi r squared is the total surface area of a cylinder. So let's take a look at our first problem, and let's try to find the surface area of a cylinder from its net. Okay, so it's exact and rounded to nearest hundredth. So let's start by writing down our formula, 2 pi r h plus 2 pi r squared. All we're going to do is put in a 3 everywhere we see an r, and a 5 where we see an h. That's it. All right, so for our exact area, we're just not going to type in the pi's. We can type in everything else into our calculator, and I encourage you to do that on your own at home. You should get 48. So our answer is 48 pi square inches. And for the rounded area, then we can actually type in 48 pi, and we should get 150.80 square inches. Number 2, find the lateral area of this cylinder. So if the lateral area is just 2 pi r h, so in this case it's 2 pi, their radius is 7, and the height of the cylinder is just the line that connects the 2 circles together, so that's 12. For exact, we don't type the pi in our calculator, we get 168, so our answer is 168 pi square centimeters. And for the rounded, now we do type that into our calculator, and we get 527.79 square centimeters. For the total, all we're going to do is we're going to take that 168 and add in 2 pi r squared. So our total is 168 pi plus 2 pi times 7 squared. Again, for our exact, don't type pi into your calculator. Everything else goes in, you should get 266 pi square centimeters. And then for the rounded answer, we type it all in, and we get 835.66 square centimeters. The next one, I'd like you to pause the video here, take a look at the cylinder, and try to find the lateral and total surface area on your own. When you're ready, unpause the video to check your answer. So here are the answers. In exact form. If you gave a rounded answer for each of these, and technically it would be wrong because the question does say in exact form here. So we want to make sure we don't type pi in our calculator and leave it like that. Number 4, soup can has a height of 4.25 inches and a diameter of 3 inches. How much metal is used to make the soup can? Round to the nearest hundredth. All right, so first of all, let's draw a quick cylinder here. Whose height is 4.25 and whose diameter is 3, which means that the radius is half of that, 1.5. How much metal is used to make the soup can? Round to the nearest hundredth. All right, so how much metal is made? That's the total can is made out of metal. So the total can is 2 pi RH plus 2 pi R squared. So that would be 2 pi R H plus 2 pi R squared. And it says to round this to the nearest hundredth, so we can type that all into our calculator and we get 54.19 square inches. Question B says how much paper is used to wrap the soup can. So for the paper, that's just the lateral area. All right, so that is just going to be this part right here. Of course, we're going to change T to L. Okay, and that's going to go into our calculators to round to the nearest hundredth. And that would be 40.06 square inches. So there's 54 square inches of metal in a soup can wrapped by a 40.06 square inch piece of paper. Last one, what is the height of the cylinder with total surface area of 200 and radius 2? So let's start with our total formula because we're talking about total surface area here. 2 pi RH plus 2 pi R squared. And we know everything. We know that T is 200 pi. We know R is 2. We don't know H. All right, we're left with that. Okay, first let's do a little bit of simplifying here. So we got 200 pi equals 4 pi H plus 8 pi. All right, it's 2 times 2 squared just being 8 and 2 times 2 being 4. All right, now if we subtract 8 pi from both sides, we would get 192 pi equals 4 pi H. Divide both sides by pi. We get 192 equals 4H. And divide both sides by 4, we get our H is 48 centimeters. That'll do it for our video today on the surface area of cylinders. Thanks very much for tuning into the video.